Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is maximum score after splitting a string. So let's go to LeetCode. Given a string S of zeros and ones, return the maximum score after splitting this string into two non-empty substrings. So left substring and right substring. So the score after splitting a string is the number of zeros in the left substring and number of ones in the right substring. So here they have given this string right here. So let's go to iPad. Here they have given us this string. It's binary string, which means it only contains 0 and 1s. Now we need to return the maximum score. What is the maximum score? Maximum score we need to return. But before we return that, what is a score? Score is defined as if you split the string into two non-empty parts. So let's say if you split this string into basically this part and let's say this part, now the score is basically zeros in left substring plus ones in right substring. So what's the number of zeros in left substring? That is actually 1. What's the ones in the right substring? That is 2. So score is 3. But is that the maximum score? Because we do still have the possibility of splitting it into multiple parts, right? Like we can split this string into multiple positions into two non-empty substrings. What I'm trying to say is, let's say if I remove these two parts right now, I could still split this substring into, let's say, two parts right here, one part and then second parts. So now the number of zeros in left and number of ones in right, let's note down. 0 is 1 and ones are 4. So what is the score now? That is 5. Isn't 5 greater than 3? Yes, it is. So this is greater than 3. So this is also another score. So 3 is another score. This is another score. Now let's try splitting at another position. That could be, now we can say right here. So these two parts, we have already done these two. So let's do another one right here. Here zeros is 1, ones are 2, again 3 score. So let's get out of this one. We already have 3 as score. How about this one? That gives me 1, this gives me 1, this gives me 2. So 2 is another possible score. How about next one? One more. Let's try splitting right at the second last index right here, because you can't leave any of these two left and right non-empty. So that is why this is the last possible split that we can do. So number of zeros are 2, number of ones here is 1. So that is why the total is 3. What is the maximum out of this? 5. So that is why 5 is the answer for example 1. Now let's see how we can do it. What would be the brute force solution for this? What do you think? So for brute force solution, what we can do is we can choose an index where we want to split this string into two parts. Given that we are choosing the non-empty, we are dividing it into two non-empty strings, and then we can count the number of zeros in the first part and the number of ones in the second part. So a simple brute force solution for this problem would be, we'll run a for loop for I in range. We'll go up to the length of the S, right? Now what we can do is we will pick a left substring and then right substring. What is going to be in my left substring is, from my S, I will take, basically I will start at the 0th index and then I go up to the ith position. So I can just say I plus 1 so that it includes ith position in the left left part, and for the right part we can start at I plus 1, and then we can just basically say leave it empty so that it takes all the values from the end. In this case, we know for the last index, since we want to actually include it, that last index, into the right part, so then we can just leave this part, we can go up to the second last index rather than going to the last index, because otherwise it will not be able to check I plus 1. Okay, so what do we do now? So I will count, although in different languages you can do this part like differently. You can run a for loop onto the left substring and then count the number of zeros, but then you can also, in Python, you can just do simply count the number of ones and zeros just like that, and then you can maintain your max score variable. In the beginning, just assign a 0 to it, and then you can update max score with either max score, sorry, my bad, it should be just max. So max score is going to be maximum of either max score or L plus R, and then we can just return that. So that is, guys, our brute force solution. This is a brute force solution, right? But let's talk about the time and space complexity for this. So here, for this brute force, time complexity is going to be, well, we are going over all the n strings, so that is taking n. But if you see this itself is also taking this count I have done. It's an inbuilt function, but it is taking a big of n complexity as well. So for each I am going over all the maximum in my left side. I can have actually n minus 1, but n minus 1 into n would give me n square time complexity, right? It will give me n square time complexity, right? So, and for space, well, we are not using any space, so that is constant. But let's see, can we do better? Well, we can definitely do better. That is why it's called brute force solution. How we can do better? Well, let's make use of some space. So what we can do is, okay, I'm just going to get rid of this brute force solution now. What we can actually do is, how about, instead of counting again and again zeros, ones, at the end of the day they are going to remain same, right? At any index, the number of zeros so far seen will remain same. So how about counting zeros and ones again and again? Let's just count the number of either of them. Let's say we count the number of ones. So I'm gonna say it, count ones is going to be equals to, so we say s dot count and just put 1 here. So this will give me count ones. So it will give me total ones, okay? Total ones. So I can even say total ones here rather than count one. That will be more appropriate. So total ones. Again, max score is going to be 0 so far. And then how about, what we can do is we are going to iterate our string from left to right. So how about as we iterate, we can count the number of zeros that we have seen so far, so that we can actually use that as the left zeros count plus total ones minus the one that we have seen so far, so that the remaining ones are in the right side, right? Okay, so we'll say zeros seen is 0 right now. What I'm saying is, let's say, I'm just gonna move this right here. It's not a really big problem, it's an easy problem. I guess I'm over explaining it. So let's say I have total ones in this are 4. 4 is total ones. Now I start my iteration right here at 0. What is the number of zeros I'm seeing? 1. What is the number of ones in the remaining array? Well, that is total ones, which is 4, minus ones I have seen so far until this index. Okay, until this index, but I have not seen anything, so that is why it's going to be 0. So 4 minus 0 is going to give me 4. So 1 plus 4 will give me 5. That is how we are going to do it for all the indexes. All right, all the indexes. Now we know, so let's just dive into the pseudocode. So what we'll do is we'll run the for loop for I in range. For I in range, we'll start at one index, 0th index, and then go up to length of s minus 1. That's because we don't want to leave anything non-empty on the right side. For left side, we will include this. So if this s at 0 is equals to 0, then what I'll do is I'll increment zeros seen plus equals 1, else once seen could be we can say once seen. Yes, we're going to have one more thing. Once seen is also 0, so we'll increment once seen, otherwise plus equals 1. Now here we will update our max score. So max score is going to be maximum of either max score or zeros seen so far. So we'll say zeros seen plus total ones minus ones seen so far. Okay, so now you can see minus ones seen. I hope it makes sense. We have already discussed this. So, and in the end we can just return max score. All right, I can return max score. Now this takes away, like, this does not introduce any space complexity also, right? It is not introducing any space complexity, and it brings down the time complexity to big O of n, because you are doing one simple count right here, which gives you a time complexity of big O of n, but then this is just single pass, which is again also big O of n, but these are two exclusive, right? These are not nested loops, so that is why the time complexity is big O of n. Space is constant, right? So this is definitely a better solution. So let's code it up. All right, let's code it up. So I'm going to have total ones seen so far is going to be s.count. I'll just put 1 here as a string. Then max score is going to be initially 0. Then I'll say zeros seen and once seen, they're both 0. Then we'll dive into for C in S. If C is 0, then increment 0 seen by 1, else you're going to increment 1 seen by 1. Now let's update the max score. Max score would be, by the way, this CH, we want to only go up to the second last value, so we'll just, we don't want to go till the very end, otherwise that will leave the right side empty. But now we can just update the max score. Max score would be maximum of either max score, what you have calculated already, or 0 seen plus total ones minus 1 seen. That is it. Now we can just return the max score. So let's zoom out and test it. I'm gonna run it on the examples. Awesome, this passes. Looks like LeetCode has changed a little bit of this UI right here. Now it's a checkbox. All right, so accepted, 100%, really good solution. Now let's write down the time and space complexity. We've already discussed it. We have brought down the time complexity from n square of brute force to n, and without even introducing any space complexity. Well, in the beginning I was talking about introducing some space. That was, you could do some prefix, prefix count of either zeros or ones, but this is good. So let's go to AlgoYogi, mark this solved. See you guys later in the next problem.